with axis rotation mark. Okay, so that's the first thing. Aiden coming or no?
No, probably not. Pretty disappointing, huh? Probably
Yeah.
makes like 75 absences for him.
Well, actually, Alden's worse than him still.
Really? Does Nolan do better?
Well, Alden is quicker at pickup stuff, but
Mm.
Alden's also a brick. So the second thing is I want you to draw a line or lines to the boundary. Okay, it's to the boundary. Now, line, if a single line is gonna be a disk method, usually, right? If you have lines, like two line, then it's gonna be a washer method. Okay, so you draw a line or lines, right? So it could be one line or two line. Okay, so what happened is we're gonna tell you the third step you had to decide. I know it seems like a lot of steps, but it's not. Decide the dx or dy. Dx usually is a vertical line, so vertical, and the dy usually the horizontal. Once you decide what is dx, so if it's dx, you need to make sure the function is in terms of x. If it's dy, then make sure the function in terms of y. So that is the very basic step. The fourth step is that they decide disk or washer, which is going to be integration from a to b of r square of x dx. Pi is going to be using this one. The next one is going to be from c to d of r square of y dy. That will be function in terms of y. This is a disk. And a washer is going to be something like pi a to b of r square of x minus r square of y dy, square of, sorry, x dx, and c to d of pi r square of y minus r square of y dy. So you can decide this one, which one to use. Lee, what are you doing?
I'm looking at the.
Oh, you're looking at that thing? Okay.
Yeah.
5. So the fifth steps, once you decide that, you gotta decide the boundaries. What do you mean by boundaries? Could be the x bound or the y bound. Okay, but depends on the graph, right? So decide the x bound or y bound and decide the boundary. Okay. The sixth step is you have a boundary, you have a disk or your washer, you have dx or dy. The last thing is actually kind of important. So I'm gonna say I'm gonna make a different color here. That says purple. If I have a function in terms of x, let's say something like y equal to x squared, is equal to the distance from axis, for x-axis to the functions. So if you have f of y, that's going to be distance from y-axis to the functions. So if you generalize every steps here, and including the last step, which is when you get to off-axis, so this step is especially for off-axis rotation, it's going to be very, very important. The last step is actually to know that, because now you just have to know how to join lines. That's pretty much it. So we can start with the first questions. Is this okay? We can start with the first question. The first question says, what if I have y equal to square root of x minus 2? And x equal to 6 and y equal to 0. So can you graph this? And we say we're going to rotate this graph around, rotate it around x-axis. Now this one you should be able to do because yesterday we did something like this. So, or on your homework you did something like this. So I want you to rotate around x-axis here. And I'll show you how I do it in a second. First of all, how many of you guys don't know how to graph square root x minus 2? Okay, so it's like a football graph, right? But it's moving right to, because it have x minus 2, it's moving right to. So it's going to be like this.
It's plus 2, it's moving left 2.
If it's inside a parenthesis, yes. And then x equal to 6 is right here. And y equal to 0. Right? Now, I'm going to show you how to draw the axis rotation mark. This is very important. Now, I want you to go back here. I want you to modify something. Draw a line. I want you to including something here from axis of rotation. So you had to draw from axis rotation, not from the boundary to draw the axis rotation, but it has to be from axis rotation or the line to the boundary. So now, what am I supposed to draw? I'm supposed to draw from here on the axis rotation, right? To the boundary like this. Does that make sense? You had to draw from that, not the other way around. If you draw the other way around, sometimes you're gonna make a mistake. I'm gonna talk about that. Okay, I did forget something on the last page. Let me including last page here. I'm so sorry. The last step is, I don't know which step is 7. Step 7 is don't forget certain thing. Don't not forget pi. Please do not forget pi, because if you forget pi, your whole thing go to waste. Don't forget pi. Huh?
Should be step 1.
Well, it's just at the end, you should double check those things. So I put it in the last step. So don't forget pi. Don't forget parentheses. Don't forget pi in parentheses. the boundaries and dx or dy. So I think that that part is also important. A lot of people don't write down dx. A lot of people don't write down dy when you're doing stuff like this. So don't forget those things. It's okay. So right here, I draw a line going to the from the axis rotation to the boundary.
Why is that axle rotation there?
Because we're rotating around x-axis.
I know, but what's it in the middle of the diagram?
Because I want. You okay?
Random point.
I want it between 2 to 6 because that's the part that's rotating. So this is the part is rotating. I can draw it here if I wanted to, it doesn't matter. But long as anything between here or here, it doesn't matter.
Gotcha.
Because we are doing rotation like this. Now, once we do a rotation, is that okay here so far? Now I will just figure out what this small distance here. So I'm start with, is this dx or dy? Is it dx or dy? Dx because the vertical line. But boundaries from where to where? The reserve the boundaries from where to where? Perfect. Do you know why it's 2 to 6? Because you stop right here and end right here. Right? Is it disc or washer? It's disc. Yes. So it's disc. Yes. Can you say that again?
Like if we plug in 0, like 0 equals we get access to that.
See how it's like you
Is it just
make it rotate?
You can do that, but I don't think it's, you need that because you can look at a graph.
Because then look, if the function was like
Yeah, because this one has two different.
yeah, it's,
So that's why.
if this function was like this, then we want.
So remember this, right? This is represented by the functions, right? Because the distance from x-axis to the curve. That's a functions, right? So would that be this is just x minus 2?
Equal 0 do that.
Y equal to 0 is the bottom bound. You don't have to have it, but I usually have it. Because you don't have to have it in this case because that's naturally boundary there.
Would that be if you were rotating around?
We're not
If you were, that would be
no, I mean, right now, just note that one may not be have to be there. You're right. Okay, so it'll be integration from 2 to 6. We know that. And this one is the pi. Don't forget pi. Don't forget parenthesis of what? Parenthesis of x minus 2, parenthesis square dx. And that's what you're supposed to get. Okay? That's what you're supposed to get. Now, the second one, I want you to rotate around y-axis. So same graph rotating around y-axis. How do I rotating around y-axis here? So where's my axis rotation? Y-axis, so we're gonna draw it right here. Is that okay?
Yes.
Okay. Now between 0 and 2, I'm gonna draw. See, do you see this is one line? Do you see that? You see it? You draw one line first, and you're gonna see the second boundary within 0 to 2 is right here. I mean, does that make sense or no? No?
Really? Why is there another boundary there?
because you are taking the larger radius, which is when you rotate the larger radius, it's going to be a big cylinder. The second radius is the hole that you had to carve out. So this look like a donut, right? Almost like a donut, but it's like kind of like a flat. Outside the donut edge is a flat, straight edge. On time. Not on time. All right, so is that okay? So do you understand this is a big R here? And do you think this is a small r here? Right? Okay. So is this dx or dy? dy, good. Damien, can you tell me the boundaries from where to where? No. Try again. Stop when? How do you get 1 to 3? You start right here. Is this the inner boundaries? Stop where? Start at 0 and where? How'd you get 3? 2. How'd you get 6? Because we are doing the white bound. Because we are this part here. We start at here, we end here with some 0 to 2. Does that make sense? Is that right?
How would you know that it's 2 unless you draw it?
How do I know? Okay. I can plug in x equal to 6 there. So 6 square root of 6 minus 2 is going to be square root of 4. Square root of 4 is 2.
Okay.
Okay, so another part is, the last part, is that disc or washer? Washer, why is washer? Because there's 2 lines, right? One a bigger line and one small line. So it's washer has a big R and a small r. Is that okay? So remember, this function is y equal to square root of x minus 2. But you want to dy, so you want to make sure the function is in terms of y, not in terms of x. So it's going to be y squared is equal to x minus 2, and the x equal to y squared plus 2. Is that okay? Yes. Oh, how the, okay, so you think about it. If you want the axis rotation to the boundary, there's only one boundary here. There's no next boundary. There's only one boundary here. But here, there's, in this region, there's one boundary and the second boundary to the region of the curve. Okay, so that's the big R and small r difference. Now, what is a big R in this case? Who said 6? Good job. 6. Does everybody agree with 6? Perva, does that 6 make sense? Okay, Perva, what would be a small r here? Not necessarily 2. It's changing. Do you see that length is changing? The small r is changing. What? No, it's changing. It's constant. Lee?
Maybe it's changing, I don't know.
Okay. Larissa? I already did that for you. That's it. Okay, yeah. Y squared plus 2. Why? Y squared plus 2. Think about it. If I plug in 1 here, right? If I plug in 1 here, what am I going to get? 1 squared plus 2 is 3. Which is distance from here to here. Do you see that? Do you see that? The distance from here to here is 3. If I were to plug in 2, would be 2 squared. That's going to be all the way to the end, 6, which just makes sense. So that is going to be y squared plus 2. So that's going to be integration between 0 to 2. Now, don't forget pi in the front, ever. And don't forget the parentheses and squares. So the 6 is going to be parentheses square minus y square plus 2 square and then dy. Don't forget dy, don't forget square, don't forget parentheses. I don't want you to forget any of those to get the points.
Original function y
This is okay, yes.
is 0 to
No, you don't need a solve. Use calculator to do all the work for you. Okay, third thing. Now the third one's kind of challenging now. So we want to rotate around x equal to 6. So think about what shapes is rotating around x equal to 6 look like. Apple, which shape do you think if I rotating around x equal to 6? Can you give me like what kind of shape?
like upside down yeah.
Like what?
It's
Upside down what?
like a dome. The circle.
I don't know what kind of dome. Dome could be defined in a lot of ways. Apple? You don't know? Okay, try to do this right now, and I want you to think about. Anybody can give me a suggestion. What it look like? What?
Look down. So if you go so it'd be like flat and like an equal. Like a very long.
I don't think Icaro is this big. I think Icaro is more like semicircle.
Yeah,
It's like a hamburger bun.
Yeah, that's perfect.
you ever know the thing that you push down and they pop back up?
It's like a hamburger bun. Okay, so rotating x equal to 6, but you must draw it like this, right? And draw the axis rotation right here, right? Did you do that? Mm-hmm. Okay, now here's the thing. Let me ask some people. Emily, what do you think is this disc or washer? It's washer, okay. Does Emma, do you think it's a disc or washer? Disc?
Yeah.
Hannah, what do you think? You don't know? Huh? Is what? It is washer? Okay, how many people think it's washer? Raise your hand. Well, why are you not raising your hand?
Confident in your answers.
How many people think it's disc? Okay, it is a disc. Because, remember, you draw from the axis rotation here, right? And you go in here. Okay. Okay, you're going from here to here. Is that okay? So that's one line. There's no two lines. You probably think about second line as y-axis. Y-axis is not part of the graph. Right? So now, here's the hard part. Is this a dx or dy? dy, good. Is a boundary from where to where? Caden? 0 to 6 is wrong. 0 to 2 is correct. The reason being is 0 to 2 is because you're gonna go here, 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 stop at 2. Okay, dy 0 to 2. What else? Is disc or washer? Yes, Vincent.
Can you re-explain the boundary?
The boundary, you start integral from here to here to here to here to here to here. It stop at 2. You don't go further because it's a y. It's rotating around y. So that's 0 to 2. So washer or disk? Sorry, is it disk or washer again?
It is.
Disk. Okay, thank you. So now here's the hard part. How do I figure out this R, the red line here? Let me. Anybody is strong enough to tell me what would be a red line here? Shh.
No, isn't that square root of y?
Fabian's confident?
Yeah.
Okay, what is it, Fabian?
2 minus y squared plus 2.
What?
2 minus y squared plus 2. And parentheses y squared plus 2.
I don't think so.
No?
Yeah, Winston?
Root of y minus 2.
Nope. 6 what?
6 minus y squared plus 2.
There's some mistakes. Small
Like
mistakes.
what?
Yes. Okay, so what Larissa says, what she says is this, but you gotta be careful. That's why I asked you to draw from the axis rotation to here. Now remember, we had to solve, it was dy, right? So we had to solve for it. So square root of x minus 2, y equal to x minus 2. So it'd be y squared equal to x minus 2, so x equal to y squared plus 2. So y squared plus 2 is a function. Remember, the function is from the axis to the curve. And here, what we want is from axis rotation to the curve. They are fundamentally different. So this is right here. This is a y squared plus 2. But it's not a red line because I'm interested about red line. But I only have a blue line, which is represents a function. So how do I get a red line? I had to take this green line, 6 minus the blue line to get a red line. Does that make sense? The 6, which is from here to here, minus the function to get this. Yes.
Squared plus 2, like, I don't get it. Like, where did that blue line come from?
Where the blue line come from? It's from the, remember, from the axis to the here is the function. The function is get by solving for x from here to here. Do you understand that part? Solving for x, you got a y squared plus 2. Do you understand that part? So you think about it. If y equal to 1, so 1 squared plus 2, that's 3, right? That's 3. Does that make sense?
Yeah.
If y equal to 0, this is a 2. Right? Y equal to 2, then that's going to give you 6 because 2 squared plus 2 is 6. So it's constantly evolving. So that's why it's that. So this R is going to be the 6, which is the green line, minus the blue, but you must have a parenthesis though. If you don't have parenthesis, it's wrong. And this is the red line, right? The red equal to green minus the blue. Am I following it? Are you following me? Emily, you got it? Okay, so then it's going to be integration from 0 to 2. Don't forget pi. It's a disk, so that's only one R. So you're going to take the 6 minus y squared plus 2, parenthesis, square dy. You got to have parenthesis, because there's double parenthesis there. Then you say, can I distribute that? No, don't distribute that. Just leave it like that. 6 minus the outer bound minus inner bound. I know it's confusing, but it takes a couple try to get better at it. But you got to willing to try this. Okay, fourth step. The fourth question. This one I'm going to ask you. I'm going to ask you to rotate around x equal to -2. No, y equal to -2. Y equal to -2. I want you to rotate around y equal to -2. Yes.
Why doesn't the last one have to be 6 squared?
You gotta draw 2 lines.
What do you mean? This square here? Are you talking about this square? Yeah, this is a disk. This is the R. And this is the R square. Oh yeah, you're thinking about washer. So I want you to rotate around y equal to -2.
Well, y equals 2. So
Okay, then you actually have to write down.
I'm trying to like think about where I'm gonna start. Well, I'll start with the next one. From -2 to 2, right? After the washer, the outer, which are no, the outer.
Draw it out, draw it out, draw it out.
Oh,
That is completely where all my confusion came from. If you remember, it's not- That's why I could move from- I don't know.
you know what a washer looks like? Or the fountain? Yeah. Yeah. If it's a circle, then it's like, and you just told me that. Where is this line? Here's the line. Okay, you forgot this whole line. Yeah. So the restriction is like, that getting the line. Between here. Yeah. Graphics is just a little.
Guys, are you guys actually working? Are you guys actually working on this?
So why do you think that was wrong?
All right. Shh. Is it dx or dy? Dx. Everybody agree?
Yeah.
Okay, so it's a disc washer. The boundary from where to where? -2 to 2? 2 to 6. And it's dx. Okay, because start at 2 to 6. Why is 2? Because start at here, right? And then stop at here. Does that make sense? Why it's 2 to 6. Apple? You got it? Okay. Parva, understand? Okay. So, is a disc a washer? Washer, so everybody agree? There's 2 lines. Okay, so what would be the inner R if you have washer here? 2, yes, just 2. Just from here to here. It's always 2. Okay, it's just always 2. It's not changing. But what would be the bigger R is what? No. Emily?
Would it be square root x minus 2 plus 2?
Yes.
Because you have that.
The reason being is this line I can break the 2 line, right? So this line here is 2, right? And this is a function. Right? Does that make sense? So therefore, I can say that it's going to be integration from 2 to 6. Don't forget pi. The bigger one is going to be 2 plus square root x minus 2, parentheses square, minus a small one and a dx. Is that good? Ready for the next one?
Wait, you on the last one we subtracted, this one we added.
It's not, because it's just look at the distance from this point. So that's why you have to draw the axis rotation. You go from here, it's 2. Don't think about adding and subtracting. Think about the distance. It's 2 plus the function. Right? You are thinking about this is subtracting. Yes, this is subtraction because you are looking at a red line, which is from the axis rotation to the curve. But the problem, the function is giving from axis to the curve. So there's difference. So that's why you have to subtract. Okay, so I'm going to give you a next one. So same thing, I want you to rotate around x, actually, y is equal to 6. Let's rotate around y equal to 6. I'm gonna draw the graph for you. Six is right here. That's the axis rotation. So think about where to where. Is this disc a washer? Is a washer? Okay, so washer is gonna have two lines. One line's from here to here. And one line's from here to here, right? Is it dx or dy? Dx, washer. From what boundary to what boundary? 2 to 6. Is that okay for everybody? Okay, so now here's the hard part. What is the big R here? 6, right? It's always 6, right? The hardest part is where the green line is. 6 minus what? Did anybody have a different answer?
Wait, let me think. What is it?
What is the D?
6. Hold on. Is it? Wait a minute. Oh yeah, okay. Yeah, 6 minus y squared minus plus 2.
No, it's not y squared plus 2 because we are looking at the x distance right now, not the y distance.
Okay,
Apple? Don't know or no? No? Okay, Samuel?
I had 6 minus square root x minus 2.
Yeah, because this is a function right here. This is a function. This is a x minus 2. Right? So this part here, this part blue part here, this part is x minus 2, right? So you had to take in order to get the green part, you had to take the 6 minus the blue part. So the R is actually the 6, which is the red part, minus the blue part, which is the x minus 2. Does that make sense?
Yes, sir.
Apple, does that make sense?
Yeah, I keep forgetting like the bottom part, like the x minus 2.
Yeah, you cannot forget that. So that's going to be integration from 2 to 6 pi. Don't forget the 6 squared minus 6 minus square root x minus 2 parentheses square dx. How many people still confusing? Hannah still confused?
No, I just didn't mention, what if it will rotate if y equals to
Rotating what?
y equals 1?
Y equal to 1? You cannot. That would be a weird because there is overlap. That's actually a good question. She said, can it rotate at y equal to 1? No, it cannot because it will be overlap. Okay, so how much time I have?
You got like 5 minutes.
Okay, we're gonna rotate the really, really hard one. X equal to 8.
Use your brain, bro. My chance to click this right there.
This one probably one of the harder one.
Oh, bro, I'm not saying rock.
Oliver's done? Yes or no?
The little small ones.
Wait, no, yeah, that's six. No. 6 minus 1 squared plus 12, right?
Daniel, I forgot a password again.
What happened to your
iPad?
yeah?
I forgot at home.
But then like
You finished soon? How many of you guys not finished? Help out Damien. Leader, you got it? Hayden, you got it? Nice.
If the first library is one mixed circle through the two, the whole thing is 6.
So, dx or dy? dy, boundaries from where to where? Washer or disk? Okay. So there is a inner radius here. And there is an outer radius here. The outer radius is going to be from here to here. Is that okay? Do you have the right drawing? Okay. So what is the small r here? R is equal to 2, right? It's always 2, right? Now here's a hard part, the red line. Fabian, what's the red line?
I did 2 plus square root x minus 2. Parentheses.
Oh, we forgot. It's dy first of all. I don't know why you use x.
Oh crap.
Okay. Anybody's confident without the answer? Okay. So what is it, Samuel? No. No. Okay, so remember the function here is from here to here. And this function is y squared plus 2, right? So how do I get a red line? Yes. The 8, so integration of 2 to 6 pi. The big R is going to be 8 minus, you have to also watch out the parentheses, y squared plus 2. And then square, because that will be the red line, minus the 2 square dy. Oh, 0 to 2, sorry. Thank you, Kaden. 0 to 2. Bye.
Yeah. Yeah, that example made it click.
Are you sure?
Yeah, I think so.
Okay. Thank you so much. Overthink. I appreciate it so much.
Video.
Do you understand that?
That's probably the only day we're gonna.
Miranda, do you understand?
Wait, when is it coming? Apple? Really not this week.
Keep forgetting the.
Maybe after.
You gotta
I think we
remember
have
the function.
I think we
Olivia,
do.
you okay?
I don't know. I just know you say that.
Yeah.
I saw.
That's the Arizona State University. That's the crowd leader. That's the crowd leader. Yeah, he's super popular.
What the hell?
He's super popular.
Selling words?
Yeah, he's like the most popular AAC crowd leader.
Like even golf.
And except he's like really big.
Okay, golf is like hard.
I don't know. Yeah, he's big muscle. Yeah.
I didn't.
Black though, yeah.
Yeah, he's been here.
I said her. Appreciate it. I mean,
You have something that goes back.
I said yesterday, so it helps.
So what happened? Did you just crack the top?
I coughed so much and hurt my back.
Like, oh, for all the.
I like.
Since now, bro, if I got sick in spring break, I would have crashed out, bro. I would have like pulled out of
Pepper.
I see you. I mean, actually, yes, we miss you.
You're David, son? We did that.
Yeah. Wait, let's play. No, here.
Hey.
I'm sure. How are you feeling? Your back hurt? I thought you was hurting this morning.
No matter what. Bring it up.
Oh, Prometheus.
Were you here to block? You watch the video? All right. Shh. You should have your homework. Yes?
Can you go over some question types? The first three. And then there's.
Okay, Ian, please get out. If you don't do homework, get out of my room. Out. 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 Now. You're gonna go outside, you're gonna finish your homework, and come back inside.
It's like for Rachel.
He was. I called him outside.
Or else anything else.
Okay.
You're just thinking this. You're thinking this equation. You should remember how we had
Because you can't have a certain
You're gonna have to shift the head. So the question is asking, make it Bobby add one from 0 to 1.
So it's 1 times x.
Oh.
Yep.
For 21, there's
Is there a center at like x equals 0? Or is it just like, is it just x equals 0?
Center X.
Center at 0? Center at 0. Yeah. That's not it, so that's
They're trying to make the extra aspects. I don't want to do that. Yeah.
It's good enough if it's not even.
I don't know. Yeah.
Peter flu comes back. Well, that was nice.
Oh, I know why I did it. No, I didn't get it. I didn't. No, I don't.
I mean, you already did part. The part C is just like look at like because it's like look over here. There's like the 3 parts. Yeah, exactly. Sign of X, plus sign of X, you. And then you know part B. Part B, you just take the right. It's like really weird. Like, okay, the part I did figure out is like this: G prime of X to the negative of X.
Okay, if you guys not working, just leave. I don't have no energy to deal with you guys not working. So Fabian, please leave. If you are working, I understand. But if you're not working, just don't get the hell out. I don't want to see you. I don't have no energy. I can barely stand, but I cannot barely walk. And you guys are not doing things. If you guys not doing things, just leave. Like Ethan just left. I don't give a shit. Like if you're working, that's fine. If you are talking about something else, then there's no reason to be here. I don't have no patience for nonsense. The work's supposed to be done before you arrive. You have 4 freaking days. So it doesn't make sense. You don't do it and come in here, and I'm putting my ass here all the time. So if you are not talking about a topic, leave. Because I don't have no patience. When I hear that, I get angry. When I get angry, my backache that hurts. So either you do stuff or you get out. Because I have no problem with 6th period. 6th period, I have no issue. Everybody's homework is always done on time. And when they are working, they are working. So 6th period, Joshua is watching the live stream for this one. And Joshua is asking, how come I live streamed, I turned my live stream on and I left it over the weekend. But so that he cannot watch that stream. So he watched the previous stream. He's like, why is 6th period so loud? Why you get angry at 6th period? 4th period? Because I never have to get angry at 6th period. You guys want to talk about your social life? No, get out. You can talk outside. I don't want to hear it. If you're here, you better talk about math. Because I have no patience for it. And there's a stream. Joshua was in Tennessee. He watched a stream before he come back. So you have no excuse, Fabian. So please leave. I'm gonna ask the 3rd time. You watch it outside. You finish, you come back in. Because I don't want to deal with nonsense. Or you can get out. You can leave. You can get out of school. I don't care. I just don't have no patience to deal with nonsense. Anybody else need to leave? Leave. Because I have no patience. Not today. So the conversation I better hear is when you talk about what happened math here. Yes.
Can you go over 57 and 58?
Wait, yeah, 15.
Okay.
45.
Take a derivative of the power rule. Using the general power rule.
Let me see. Take the power rule.
So when I was doing 58, I did the first part, it's already fine. But like this is the part I got confused on. Like I was following something that told me when you take the derivative, I did the first part. G of x, you have to take the derivative of this, right? But they split it up. This is the 0th term, and then this is the 1st term. Is that like? Because the 0th term is like 1, because if you put in like there you go. And then it's just when you take the derivative of it, it'll just be equal to 0, so it makes it easy. And then like that was fine up until this point right here. They substituted like k equals n minus 1 and k plus 1 equals n. I didn't understand like who did this. This was like Math GPT.
Okay.
But I didn't understand like they plugged it in. But I didn't understand like where they got it from or how. What does this have to do with anything?
Basically, they want to switch back to, you see this is n equal to 1. They want to switch back to n equal to 0. If you switch back to n equal to 0, it becomes the same equation.
But I wouldn't have had to do that if I just started from 0, right? Like if I just use this same function here instead of like starting at 1, you know? This is like the start of 0 function, like that.
Right.
And could I not have taken derivative from just this? Would that have caused a problem?
So it's 2n plus 1 times n. You still have some more? Yes. Okay, good. And you realize the log of 2 plus 1, right?
You can take derivative to k plus 1.
So you have x all over.
And I forgot that rule.
Yeah, 0 factorial. Are you saying how did I get here from here, or?
No, like, could I have done this same thing just by, like, taking derivative of this only? So I wouldn't have to use this k stuff. But this is just kind of like a reverse.
Right.
Because you started n equals 1 now, but you're trying to get back to the original function, n equals 0. So it subtracts 1 from it. And this k can be any variable. It doesn't have to be k. Let's substitute.
So you're doing the second part you have the issue with, not the first part.
Yeah, no. The first part I
First
understand.
part's fine.
Easy. Okay. The second part is when I had the problem.
Two n plus. But if you take a derivative,
Oh, yeah, and it's okay to like leave like 2n. If I'm taking derivative, 2n factorial still stays the same, right? And -1, like if I had -1 to the n, it'd still stay the same, right? Like, just move it down with it. Only thing that would change is the x to the power.
two and let me work it out first. I'll get back to you. Get back.
And then after that was 59, because that one I didn't know. I think it's taking two different.
59 is just take two derivative and
Yeah.
then add it to the original function, and it should end up equal to 0.
Take two derivatives.
Yeah, take a second derivative.
And okay, because what it also told me to do is split them. Is that what you
Why
would
do you have to split?
Huh?
Oh, don't split.
Just keep them as one.
Who told you to split?
This math GPT person. Don't split.
Well, hold on a second.
Because it just leaves this one as a constant. The -1 over. I mean,
Yeah, let me work it out first.
Okay.
I'll get back to you.
Now, that's your X1. See with that.
And then this.